This is Nitin Dahad with the Times, and I'm today visiting the offices of Empower Semiconductor in Silicon Valley and talking to Tim Phillips, who's the founder and CEO. Tim, hello.
Hello, Nitin. How are you?
Good. You just announced a new platform. Before we talk about Crescendo, which is your new platform, tell us a little bit about the company and your value proposition.
Yeah, sure. So we're Empower Semiconductor. We've been around for about a decade. Our proposition is power management speed, delivering energy at very, very high speeds in tiny spaces.
Okay, that's very brief. Well done. So I think your background is in the power space. You're ex-Infineon, IR,
Right.
And then you also started Navitas. Yeah,
Yeah, I helped in the beginning with Navitas as well.
So
yes.
so you've got that power semiconductor pedigree.
Yes.
But what have you brought to the company here? I think you brought some sort of innovative thinking in terms of architectures to deliver power more efficiently and with more performance for the AI age, I guess.
Yeah, that's correct. So with all new power structures and power supplies being pretty clear that density was the problem for all GPUs, new ASICs, high current, high performance computing systems that were in place. So we did Empower come up with something called FinFast technology.
Yeah.
It basically uses standard FinFET CMOS technology, processor technology, to deliver power very efficiently at extremely high speeds. And what that enables is just to shrink all of the magnetic capacitive elements in the system, basically deliver energy on demand instead of having energy storage required in the system. That enables us to achieve densities about 5 times higher than anything else out there in the market.
Okay, and I think when we were talking earlier, I think one of the key things is your FinFast architecture and the magnetics, which is basically enabling you to remove a lot of the capacitors for that storage.
Yeah, that's correct. So in most systems, there's hundreds, if not thousands, of capacitors, MLCC capacitors, SP caps that sit right up underneath the processor. What our technology enables is the removal of all of those energy storage elements in a system, just eliminate the caps. And our FinFast technology enables to match up very high frequency magnetics, co-integrated in with our silicon, to enable us to get very high bandwidth so that we can attach our power chips right up underneath the processor for direct vertical connection. This can save 10 to 20% of the system's energy loss.
And it's using a standard silicon process.
That's correct, yeah, standard FinFET technology.
And you're delivering this as a chip, not IP.
Correct, yeah, we sell it as an integrated power block.
Okay, so tell us maybe a little bit more about Crescendo and the platform.
Yeah, so Crescendo is our latest innovation that we're bringing to market. It's a culmination of many years of R&D development to get the magnetics right, to get these wide bandwidth capacitors right, to get the FinFET switching at the right speeds, just correctly, all integrated in together with new architectures. So we're introducing it to market now. We're designing with customers. The chip will go to production at some point during 2025. But it's meant to scale up thousands of watt type systems very efficiently with tiny power supplies. Basically removes power from the top side of the board and enables you to bring power right up vertically up underneath the processor.
And I think earlier you showed me a picture of a GPU and all the capacitor banks there. And
That's
I think
correct.
you've got a board here just to
Yeah,
show
this is
sort of how that.
a good just picture of one side of a board. But this is a good example of a Crescendo where you'd have a CPU sitting right up underneath, up on top of the board here. You'd be able to remove the power off from the top side of that board and basically move it right to the bottom side of the board, directly underneath the processor for vertical current to go right up through the board to the processor side. Normally, there would be thousands of capacitors sitting here down underneath the board. Instead, we can put our chips there.
Okay, and tell me in terms of performance and efficiency, some kind of benchmark figures.
Yeah, so we're able to achieve or beat a typical standard industry type regulator in terms of efficiency. What this part allows you to do, because of the location, the speed that we operate in 5x the density, we can actually save 10 to 20% of the total overall system energy by going to this. So you can get power supply efficiencies that are similar to better than what you get today, except we enable the savings of massive amount of transmission loss that typically runs as you run current through a PCB, you lose a tremendous amount of energy. This eliminates all of that energy loss.
And the whole, it benefits those who are developing the NPUs, the AI chips.
Exactly.
So I think those are the ones you're targeting initially.
Yeah, so the bandwidth does two things. One, it eliminates the need for energy storage. We supply energy on demand. The second thing that it does is all of that bandwidth, also nice, clean, fast regulation. So processors can scale up voltages up and down very, very quickly, typically 1,000 times faster. We move voltages and currents in nanosecond speed instead of microsecond speed. So that enables them to move things. Also get very nice regulation, especially during transient response with changes in loads. We're able to really maintain very fast regulation with a low voltage dip on the processor.
And tell us about the company. So you've raised, what, 75 million so far?
Yeah, the last 2 rounds are 75 combined. We've done a little bit more than that over our history, and of course, we'll probably do more fundraisers over time. But that's right, we've in that area, yes.
And how's it going? You're generating
Yeah,
revenue?
we're in revenue this year, ramping revenue. It's ramping pretty quickly. Next year is a big ramp, and then 2026 a big breakout year for us as these systems take a little bit of time to ramp up in revenue.
Okay. Well, Tim, thank you very much.
Thank you, Nitin.
Thank you.